Hi and welcome to the new course Azure DevOps Getting Started. In this course, I will try to introduce you with a new software development lifecycle called DevOps. I will give you an overview on what the DevOps tools can do for you when implementing continuous delivery in DevOps. I will also show you the various parts of the components like the boards, repositories, the build and release pipelines, artifact stores, and test plans that are available in Azure DevOps. I will go through each of the individual parts that are available as a separate offering. I will also show you how the product work together and can deliver a seamless experience that enables you to build a DevOps and continuous delivery strategy in your organization that is secure and compliant by default. My name is Prashant and I will be the instructor for this course. I have divided this course mainly in two chapters. The first one is what is DevOps. Under this chapter, we will discuss about why we should use DevOps, comparing DevOps with traditional SDLC lifecycle, DevOps goals and benefits, and what is DevOps culture. The second chapter, which will talk about Azure DevOps, specifically about Azure DevOps services. I will try to introduce this basic components of Azure DevOps like boards, repos, pipelines, test plans, and Azure artifacts. Let's start our first chapter, DevOps. Why would I need a product that has so many different parts for delivering our softwares? Can't we just keep it simple? Well, Microsoft created a product suite for us to help us navigate the new normal in software deliveries called DevOps. You might have noticed that in our industry, many organizations are moving towards an agile way of working. This means that the wonderful approach that we have embraced in the past decades is now fading away. We are in a major paradigm shift and we are moving away from the engineering way of thinking about the software delivery towards manufacturing approach. This means we are now looking at the concepts that are used in manufacturing mass goods, like example cars. In fact, a lot of techniques that are embraced come from leading manufacturing principles developed by the car industry, which was led by Toyota. Things like scrum, kanban, and the add-on code, etc. All the concepts that have been translated into software delivery, we have either used a set of independent tools for your agile scrum board or lean kanban board, which for example is Jira and Trello. You can use a build tool like Jenkins, TeamCity, Bamboo, and you can find many different tools for release management like Xavier Labs, Excel Deploy, Jenkins, Octopus Deploy, etc. But the Azure DevOps, you have a tool suite that can be used for all these things and have a one secure, fully traceable and easy to use tool set that you can do not have to host or maintain. What is DevOps? Let's see the definition of DevOps given by Microsoft. DevOps combines development and operations to unite people, process, and technology in application planning, development, delivery, and operations. DevOps enables coordination and collaboration between formerly siloed roles like development, IT operations, quality engineering, and security. Teams adopt DevOps culture practices and tools to increase confidence in the application they build, respond better to customer needs, and achieve business goals faster. DevOps team helps continually provide value to customer by providing better and more reliable product. DevOps influence the application lifecycle throughout its planning, development, delivery, and operation phases. Each phase relies on the other phases, and the phases aren't role specific. A DevOps culture involves all roles in each phase to some extent. In this topic, we will try to compare and justify the importance of DevOps over traditional software deliveries. Traditional methods often focus on planning with big releases, which are much riskier due to the amount of work involved. When working in longer cycles with infrequent releases, things can often become complex quite quickly. You will be up against hard deadlines compiled with a list of added features. While the big releases look impressive, they are often an inefficient way of working. DevOps, on the other hand, takes a different approach. They run with a smaller releases that are often much easier to understand and test, making the release a lot less risky. It's also easier to manage its things don't go to the plan as there isn't so much to fix. By running more frequent small releases, DevOps enables your business to quickly respond to any new customer needs or requirements. Planning. Traditional methods often use planning and scheduling systems to help manage any development. Within traditional methods, there are typically a lot of moving parts to the development cycle, making a schedule quite a challenging task. DevOps is built on continuous, smaller releases and automation from dedicated team, making it much easier to schedule. You will be planning for a coming week as opposed to a few months, giving you better visibility of your team's time. Plus, by having a dedicated team working on this, you will be able to coordinate everything effectively rather than having to schedule different people in different roles. Feedback. Traditional methods feedbacks were giving when full-fledged product has been delivered to the customers. And then it will be hard to take those feedback and try to change the product. DevOps enables you to quickly react to those feedbacks thanks to the DevOps process, meaning you will be receive quick feedback in a small release and it will be easy to implement those. Culture. Traditional methods are often risk averse. The culture is built around trying their absolute best to not harm the business, when result in them having a lot of pressure to get them perfect. And when in reality it is anything is ever perfect. I don't think so. DevOps create a culture very different from this. They adopt a fail early culture, understanding that failure is inevitable. That's why they have created a strong structure and a process around controlled failure through the continuous testing, smaller deployments, and automation. The team adopts the mindset of sooner you fail, the smaller the impact and the quicker you recover. Focus. Traditional methods often complete a task by doing their part and passing it on to the next person. They will they will be on so focused on completing a task by meeting the deadline rather than making sure that is done is deployable. Using this method can often lead to a loss in quality and lack of accountability. DevOps, on the other hand, focus on creating a cross-functional team where everyone's accountable for the task being completed. All team members will be working towards the same goal and will therefore have the same definition of completed task, which is creating a high quality software. They are driven by the bigger picture rather than focusing on a specific task they need to carry out. DevOps goals and benefits. When a team adopts a DevOps culture, practices, and tools, they can achieve amazing things. Accelerated time to market. Through the increased efficiencies, improved team collaboration, automation tools, and continuous deployment, teams are able to rapidly reduce the time from product inception to the market launch. Second, adapt to the market and competition. A DevOps culture demands teams have a culture first focus. By marrying agility, team collaboration, and focus on customer experience, team can continuously deliver value to their customer and increase their competitiveness in the marketplace. Third, maintain system stability and reliability. By, by adopting continuous improvement practices, teams are able to build in increased stability and reliability of the product and services they deploy. They, these practices help reduce failure and risks. Fourth, improve the mean time to recovery. The mean time to recovery metric indicates how long it takes to recover from failure or breach. To manage software failures, security breaches, and continuous improvement plans, teams should measure and work to improve this metric. DevOps culture. To fully implement DevOps, you must adopt a DevOps culture. Cultivating DevOps culture requires deep changing in the way people work and collaborate. When organizations commit to DevOps culture, they create an environment of highly performing team to evolve. While adopting DevOps practices automates and optimizes processes through the technology, without a shift to a DevOps culture within the organization and its people, you won't gain full benefit of DevOps. Pause this training here and try to go through the picture on the screen and see what are the qualities required for a team to adopt DevOps culture. Key components of DevOps culture. First, collaboration, visibility, and alignment. A hallmark of healthy DevOps culture is collaboration between teams. Collaboration starts with visibility. Development, IT, and other teams should share their DevOps processes, priorities, and concerns with each other. By planning their work together, they are better positioned to align on goals and measures of success as they relate to their business. Second, shifts in scope and accountability. A team aligned, they take ownership and become involved in other lifecycle phases, not just the ones central to their roles. For example, developers become accountable not only to the innovation and quality established in the develop phase, but also to the performance and the stability their changes bringing in the operation phase. At the same time, IT operators are sure to include governance, security, and compliance in the plan and develop phase. Third point, shorter release cycles. DevOps teams remain agile while releasing software in the short cycles. Shorter cycles make planning and risk management easier since progress is incremental, which also reduce the impact on system stability. Shortening the release cycle also allows organization to adopt and react to evolving customer needs and competitive pressure. Fourth point, continuous learning. High performing DevOps team establish a growth mindset. They fail fast and incorporate learning into their processes. They strive to continually improve, increase customer satisfaction, and accelerate innovation and market adaptability. Let's start our new chapter, Azure DevOps. Azure DevOps supports a collaborative culture and set of processes that bring together developers, project managers, and contributors to develop software. It allows organizations to create improved products at a faster pace than they can with traditional software development approaches. Let me introduce you to the toolset of Azure DevOps that is specifically built and designed to help you with the implementation of modern continuous delivery and DevOps as we just discussed. The product suite consists of Azure boards, repos, pipelines, test plans, and artifacts. Azure DevOps also has wiki and dashboard capabilities. The individual tools work together with all kinds of open source tools and commercial tools that are out there. Azure DevOps integrates very well with itself that will give you an end result with an additional boost. I will show you this in the demo throughout the course. End-to-end traceable code that is deliverable to the production in secure and compliant way without you needing to build or create the integration between the various parts. Let me go through the different part of the products one by one in more details. Let me start with explaining what Azure boards can do for you. Azure Board is a web-based service that enables team to plan, track, and discuss work across the entire development process. While it supports agile methodologies, including Scrum and Kanban, Azure Boards provide a customizable platform for managing work items, allowing teams to collaborate effectively and streamline their workflow. You can track and manage work and access various functions within each of the following hubs. For example, work items. In work item blade, you can access list of work items based on specific criteria, such as those assigned to you, ones you follow, work items you have viewed or updated. Boards. View boards items as cards and update their status through the drag and drop. Similar to physical sticky notes on a whiteboard. Use this feature to implement Kanban practices and visualize your workflow for a team. Backlogs. In backlogs, we can view, plan, order, and organize work items, including using a product backlog to represent your project plan and a portfolio backlog to group work under feature and epics. Sprints. You can access your team's filtered view of work items based on a specific sprint or iteration path. Assign work to a sprint using drag and drop from the backlog. Iterate with the backlog list or card-based task board to implement Scrum practices. Queries. Generate custom work item lists and perform various tasks such as tries work, make a bulk update, or view relationship between work items. Queries also allow for creating status and trend charts that can be added to the dashboards. Delivery plans. Management teams can view deliverables and track dependencies across multiple teams in calendar view. Delivery plans supports tasks such as viewing up to 12 teams backlog, custom portfolio backlogs and epics, and work that spans several iterations, that is sprints. Users can add backlog items to plan, view roll-up progress of the features and the epics, and dependencies between work items. Analytics view. Creating highly sophisticated Power BI reports based on Azure Boards data. Access default analytics view or create a custom view in the analytics blade. Let's start our first demo, Azure Boards. But I'm already logged into my project, and here you can see I have one project here and my organization is PRSHU 007. Let's open our project here. We have repos, pipelines, test plans, and artifacts. In the board, we have different blades, work items, boards, backlog, sprints, queries, delivery plans, and analytics views. In the work items, we have all the work items which are created by our team, and we can see those work items over here. The work item can be a task, can be a user story, epic, feature, or bug. So if you want to create a new work item over here, so we can see in new, we can click on this new work item and what type of item you want to create. You want to create a bug, epic, or something else. So for example, I want to create a bug. So let me just click on it, and here we have to title this bug. So for example, bug 1, and what is the state I want to give it. So since it is a new, so we have this new one, and why I'm creating it, it's a build feature or defect reported, whatever it is. So I'm saying it's a build feature. The reason is, and the area where I want to keep this, so area will be, we have only one area which is GSWP, and we can give it to some other sub areas. And iterations means the sprint in which I want to add this bug, so that my team can start working on it in that particular iteration. So right now I'm keeping it into my backlog items, not in the sprint, so it is going into the backlog. Over here in the Repos tabs or system info and acceptance criteria, we can fill up some information. So for example, this is a bug which need to be resolved, and you see here we have all this text functionality. So if I want to add how many steps or what needs to be done, so for example I'm just writing this step 1. So if I write like this, automatically it is converting it into the indentation, then step 2, and so on and so forth. I can add some extra formats as well from here, indentations, and if you want you can add here other work items. So for example, here you want to link something, mention the pull request, add some images, add some link, create some link, so you can add those also into this bug. Coming up next, what system information is required, we can fill it up. Acceptance criteria, it is most important. That acceptance criteria means what is the acceptance criteria once this bug is closed. So for example, users can resolve, user can log in correctly to the system. So for example, our bug is related to that users are not able to log into the system, and now the output of this will be users can log in correctly to the system. So once this bug is closed, automatically users will able to log in into the system. So this is the acceptance criteria, and some in your case it can be more than one acceptance criteria. Now in the discussion pane, when we are working on it, we can add our comments that steps 1 is finished, and once we will save it over here, it will go down in the discussion. Okay, now once we have given all this information in the left side of a bug, then coming to the right side, the details. So here first of all we have the priority. So what is the priority of this bug? Is it critical bug which needs to be fixed as soon as possible? Then we can make it 1 high priority. What is the severity of the bug? Is it critical, high, medium or low? We can give accordingly, like critical, or maybe it's a high. How many efforts is required? So we can give user stories, points to this bug, 1 point, 2 point, how many points is required to work on it. So what is the complexity? So for example, I want to give 8 user stories, so it's complex enough to give it 8 user story. It's a team decision to define the complexities, that 1 complexity is what, 2 complexity is what, 3 complexity is what. Those are team's decision to define those complexities, and these are mostly in the order of 1, 2, 3, 5, 8 and so on and so forth. And we want to add more remaining items or something like that, we can add those as well. We can define the activity, that which kind of activity it is, deploy, design or development. We can save it. If we want, we can, let's save it first. So for example, we want to save it, and now you see the state is new. We can change it to approved, then committed, then done, then removed. We can make other state as well once we will work on it. I want to make this bug as a relationship with the other bugs. So for that you can see here we have add links, and if I click on the existing links, then I can see like parent, and then I can give other product items here. So maybe this bug is related to notify the user about any change or provide related items to frequently brought together, something like that. If I want to make connection, then just here okay, and you can see now my bug is connected with the parent task, which is number 292. In this bug, if I click on this history panel, you can see all the history whatever somebody has updated. So for example, this is a new bug, so of course it is only I who worked on it and updated it something. But in teams it can be possible that many people work on some user stories or some bugs or some issues, and they keep on updated, so you can get all the history over here. In this tab over here in the links, we can see the links dependencies of your work item with other work items. And if you want to add some attachments over here, you can attach as well. So this is about the work items. Now going to the boards. Here we can define our own board, whatever we want. So but boards is something like where we can see our work items, that which are work items which are in new, which are is doing phase, which are is done phase. So those kind of stuff we can see in the boards. So and let's move on to the next one, which is backlogs. So in the backlogs you can see we have all these work items. So let me just change epic. So here you can see how many epics we have. If I want to change it to features, how many features we have, we can add, mix and merge over here. So I am just giving it all the work items. So you can see we have these tasks over here, then we have some bugs. If we want to see the parents as well, then we can do this like parents on, and now you can see which work item is child of which work item. So for example, we have this epic over here, and now epic is having one feature and this feature is having one bug here. For unparent features, we have so many work items created, and we have one work item over here. Moving on, if I try to do forecasting here, so forecasting means that I am trying to use Azure DevOps feature to forecast that how much work is there and in how many sprints I can complete my work. So for that, if I open this, then it will categorize my work items into each sprints, and then we can understand that how many sprints are required to complete our work. Here you can see we have a velocity. So if our team's velocity is like, for example, 20 story points, then we can see we require only 3, 4, 5, only 3 sprints required to complete these work items. And if our team's velocity is 30, then only 2 sprints are required. So it's very easy to forecast your work, that how much sprints are required for completing your task. Let's move on. Then we can see the mapping over here. So in the mapping, if we want, just a second, let me remove this forecasting first. So mapping, if we want to map our work item to some features, then we can map it very easily using this mapping tab, and we can map it like this. So it will map with this point actual on purchases. It's very easy. And now in the planning, this is where we can plan our work, that we want to move some items to the sprints. So for example, current sprint, this is going on, and we have this 15 efforts points for working on. And if I want to add some more into this, then we just have to drag and drop over here, And you can see it has increased the efforts of that current sprint. We can also see this backlog into the board as well, that what is going on right now. So there are so many work items are in new. There are some expedite here where we are working, and we have some doing phase, and there are some done phase as well. So some task is already completed, some are in progress, and some are in new state. So for example, if we want to move this over here, that means done. So everybody will get to know that this task has been completed, and we can update our comments over here. Now if we want to update this board according to our requirements, so we can go to settings here, and in the settings we want, for example, for bugs, we want to see the bugs. We want to see the bugs with their priorities also. So for example, I am writing here priority and save and close. So now you can see all the bugs is having severity, area path, as well as the priority of the bug. So if I go down here, you can see the priority of the bug. If I want to change the styles, for example, card style as like rule 1, and if I want to add a rule here that if the priority of any task or any work item is 1, then the color will be red. So I will use the card color will be red if the priority is 1. So let me save it, and now you can see whatever the work item we have here, if the priority is 1, it will become red. So for example, here you can see this priority 1, it is red, and we have some red here. Now for example, I want to change the priority of this to 1, and it's automatically going to be red, so that we can focus on these work items and complete them before other work items. Over here in boards, we have the swim lanes. In the swim lanes, we have this something called expedite. For example, if you're working in a sprint and suddenly some task come up in the middle and we have to expedite that task, then we have this different high speed lane where we can work on the high priority to complete that special task. So we have this expedite lane, we already have it in our board. So this is an expedite lane which is above all the lanes, and we have to prioritize it, and we have to make it done as soon as possible. So design will be done, and once design is done, then we will develop it, test it, and complete our process. Now moving on to the sprints. So sprints, as I told you, these are the small iterations where we will define that what is required to be done in that small iteration, and there will be some release after each sprint, so that we can produce small features or changes to the product very frequently. In the sprints, it's like this is the real board where the team works on. Team discuss this every day, and every day in the stand-up call they discuss that what they are working on, what they have completed, and what they are going to work on. And once they will complete some tasks, they move them as like right now in progress, and they move them in the done state. So this is how the sprints works. And the sprints, we have this sprint backlog where we define the sprint and there put them some assignment that who is working on what, etc. In the sprint, we have this capacity tab. In capacity, we can define the capacity of the team. If team is having the day off, like holidays, seasons, then we have to add those holidays over here. And if somebody is going on holiday, we can add that user that is not available for such and such date. So this is telling me what is the capacity of our team to work on the sprint, and with the help of this capacity we understand that how much we can work in a particular sprint. Analytics, this is more complex side of DevOps, which is you guys don't require. It's a only getting started course, but just to give you brief analysis, analytics is something give you an overview of the sprint velocities and burnout charts. These are the techniques. With the help of these techniques we understand what is the capacity, what is the velocity of our team to complete in each sprint, that how much task we can complete as a team in a sprint. Then we have something called queries. So in queries we can write down our own queries to dig some special kind of user stories or work items. So for example, here I am just writing a simple query that I want something from my product backlogs whose state is not equals to done. So I am trying to get everything which is not yet done. If I run this query, I will get all the work items which are not yet completed. Either they are new, they are committed, approved, but not completed. We can have a little bit complex queries also here, which are require some relationships. So for example, these are the flat queries. We have work items and direct links. So here we can define like I want work items which is tagged with test cases, like they do have test cases. So let me try to run this query. Now we can see there are some work items which are having test cases here, all the work items. And now if I want opposite of it, like which are not having any test cases, then return items that do not have any matching links and run the query. And now this is telling us that what our testing team required to be done. We have these work items which does not have any test cases, so we can ask our testing team that please write down the test cases for these work items. We can save this query by giving some name, query 1, not query 1, you write your own special name. So and we can hit save, so it is saved over here, and whenever we want we can query it. So you can see query 1 is saved here. Delivery plans, analytics views is not required for you guys right now because it's a getting started course. But if you want, just let me know. We can go deeper into this boards, and I will create an advanced course on only on Azure DevOps boards. Azure Repos. Azure Repos is a set of version control tool that you can use to manage your code. Whether your software project is large or small, using version control as soon as possible is a good idea. Version control systems are software that help you track changes you make in your code over time. As you edit your code, you tell the version control system to take a snapshot of your files. The version control system saves the snapshot permanently, so you can recall it later if you needed it. Use version control to save your work and coordinate your code changes across your team. Azure Repos provide two types of version control: Git, which is distributed version control, and Team Foundation version control, which is a centralized version control. Our focus will be Git, which is now widely used in a major organizations. Under version control, let me discuss some basic concept. Repository. A repository is a location for your code managed by version control. Branches. Branches are lightweighted references that keep a history of commits and provide a way to isolate changes for a feature or a bug fix from your main branch and other work. Committing changes to a branch doesn't affect other branches. You can push and share branches with other people on the team without having a merge the change to the main branch. Branch policies. Branch policies are the important part of Git workflow. You can use them to help protect the important branches in your development, like main branch. Branch policies enables you to isolate work in a progress from completed work in your main branch. It guarantees that changes build before they get to main. Policy also limits who can contribute to specific branches. It will enforce who can create branches and the naming guidelines of the branches. It will automatically include the right reviewers for every code change and also enforce best practices with required code reviewers. Commit. A commit is a group of changes saved to your local repository. You can share these changes to the remote repository by pushing the changes to the origin branch. Pull request. Create pull requests to review and merge code in the Git project. Pull requests let your team review code and give feedback on changes before you merge it into the main branch. Pull requests can come from either topic branches within the same repository or the branch in the fork of the original repositories. Reviewers can step through the proposed changes, leave comments, and vote to approve or reject the code changes. Next demo is Azure Repos. So we are on our Azure DevOps project, and here you can see we have our repos here. In the repos we have files, commits, pushes, branches, and tags, and pull request. In the files we have here whatever project we have, but before going to files, let's go over here in the top ribbon. In this top ribbon we can see it is my project, then it is my organization, then we have this project name, then we are going inside the repos, and then we are going inside files, and we are seeing the files of this repository. And from this sign you can see that this is a Git repository. I will show you how to create a new repository. So you can go here in the drop down and you can see in here we can create a new repository. What is the type? So as I told you earlier, we have DevOps support two types of repository. One is Git, another one is TFVC. I am just creating a Git repository. I have to give one name here. So for example, my demo repo. So I'm just creating my demo repository here. I want to add a Git file. So this Git file belongs to which technology? For example, you see so many Java, Jekyll, Julia, so many things. Let me create a Terraform. It's easy. And create. It will create one new repository, my demo repo, and it has added the git ignore file. In the git ignore file you can see it will not allow these files to be transferred to my file and to my repository from my local repository. And you know that Git is a distributed repository, so we can clone it as well. So just click here and clone, and you can clone this repository to your local repository using VS Code and some other ID. Now in the readme we have something here. So for example, if I want to update this file, so we can update it here, or we can clone it and update in our local repository. In the commits, this is a new one, so nothing is there. Let's go to our older repo. Here you can see there are so many commits done by our team members, and here you can see our team member has created one branch, and then branch is creating one pull request and merge it with the original branch. So if we want to see what are the changes here, we can click on it, and then we can see what are the changes over here. So it is removing some files, adding some files, etc. And here we can see who has done what, and in the details who is authored, who has committed, and who posted these changes. So we can see everything as audited here for each commits. In the branches we can see we have so many branches here. So we can work on each branch, and that branch will be individual, and it will the changes will be safe from the other branches. If let me go to the demo branch and let's create a new branch over there. So if I'm here in the main branch, let me try to create a new branch, for example develop branch, and based on the main branch, because we have already only one branch here, so create a develop branch. And now in this branch, if I want to update something, so let me go to our readme file and try to edit it. One more point here and adding extra point, and let me try to commit, and I want to update my develop branch. That's fine. And now you can see this fifth point is added, adding extra point. And now it is asking me that create a pull request. Since I have updated my develop branch, so I should create a pull request to the main branch. Over here you can see, so I have created this pull request, and here in the files you can see what are the things which are getting updated here. Side by side. So in the side by side you can see what is the old value of your file and what is the new value of your file. So I have added only this new line here, and in the overview we can describe what this pull request is related to. We can add reviewers over here. I'm adding myself to review my code. You can add your team members, product owners. If I want to add some task, I can add my task or any work item over here with this pull request, and once this pull request is completed, the task will automatically get closed. If I want to add some tags, we can add those tags as well. So let me create it, and since it is created, now it is asking me to approve it. So let me approve also. Over here I can add my comments. I can add my comments that looks fine to me, or I want to add some comments like please update some new feature, or not new feature, please correct something which I feel like should be corrected. I can add over here. If I want, I can wait for the author to come back again and reject it or approve with some suggestions. I have just approved it, and now it is asking me to complete. I can complete it, mark as a draft, or abandon this pull request as well, but I would like to complete this pull request. Now it is asking me complete associated work items after merging. I don't have added any work items, otherwise it would have completed that work items, and delete the develop branch after merging. No, I don't want to delete my develop branch, and customize merge commit messages. That's fine. So complete it. And this automation has automatically pushing my changes to the master branch after checking with the 4i principle. So one the developer who is creating this pull request, and the reviewer is checking this pull request. You can add more reviewers here, so it can be go through 3 or 4 people for review it. And now if I go to my repository here, so this is develop branch. Let me go to the main branch, and now you can see we have this 5th point adding extra point. And now in the history you can see I have created one branch here, and then pulling that branch into the master branch and merging it. And in the details we can see what changes I have done. So everything is audited over here in the Azure DevOps, so you get to know in future that who did what, so that if something goes wrong, we can revert back those changes and resolve those issues as quickly as possible. Now in the branches, I haven't showed you one important thing, that in the branches we have these something called branch policies. So in the branch policies, we can add some policies on the branches to make those branch more secure. Otherwise, anyone can come and update your branches. But we can add branch policies like require a minimum number of reviewers. So I'm saying yes, I require minimum number 2, 4, 7. But right now I am only one, so I'm adding it as a one minimum number of reviewers. I will checking this right now because it is saying allow requester to approve their own changes. Otherwise, if I uncheck it, then I cannot approve this and it will block me to approve my pull request. So I'm allowing it. If you want, you can add more policies, check for the linked work items, check for comment resolution, limit merge types, etc. We have other options also, but we don't have to go that deeper into getting started course. So let me just go to my repo once again and try to update this one, because right now we have policy into the main branch that only pull request changes are allowed in the main branch. I cannot update my main branch directly from here. So if I want to commit one point here, checking commit directly to main branch. So let's see this will work or not. So try to commit in the main branch, commit, and you see it is returning me error. Pushes to this branch is not permitted. You must use a pull request to the updated this branch. In this case, I have to create a pull request and then only I can update this main branch. So what I have to do, I have to create a feature branch or some other branch name and then create a pull request. So feature branch I have created and commit. Now it has created a new feature branch and it is pulling my changes to the main branch, and then I create a pull request and now automatically it is asking for the approvers. So I will approve my change and complete it, and it is asking me complete associated work item. There is nothing there, but I want to delete. I don't require this feature branch, so I just deleted it. Complete, and Azure DevOps do all things for me. So let's go to the files, and now you can see checking commit directly to the main branch. I was not able to do it, and how I do it, I have to create a pull request to the main branch and then only I was able to do it. So that's all in Azure Repos demo. Azure Pipelines, my favorite. Azure Pipelines automatically builds and tests code projects. It supports all major languages and project types and combines continuous integration, continuous delivery, and continuous testing to build, test, and deliver your code to any destination. Continuous integration, what does it mean? Continuous integration, also called as CI, is the practice used by the development teams to simplify the testing and building of code. CI helps to catch bugs or problems early in the development cycle, which makes them easier and faster to fix. Continuous delivery. Continuous delivery, also called as CD, is a process by which a code is built, tested, and deployed to one or more test and production stages. Deploying and testing in multiple stages help drive quality. Continuous integration systems produce deployable artifacts, which include infrastructure and applications. Automated release pipeline consume these artifacts to release new versions and fixes to the existing systems. Continuous testing. Whether your app is on premises or in cloud, you can automate build, deploy, test workflows and choose the technologies and frameworks. Then you can test your changes continuously in fast, scalable, and efficient manner. Continuous testing offers you maintain quality and find problems as you develop. Choose your preferred test technology and frameworks. With rich analytics and reporting, when your build is done, review your test results to resolve any issues. Deployment group. A deployment group is a set of deployment target machines that have pipelines agent installed. A deployment group is just another grouping of agents, just like agents pool in pipeline. You can set the deployment target in the pipeline for a job using deployment group. Stays. A stay is a logical boundary in the pipeline. It can be used to mark separation of concerns. For example, build, QA, and production. Each stage contains one or more jobs. When you define multiple stages in a pipeline, by default, they run one after the another. You can specify the conditions for when a stage runs. Let's start our next demo, Azure Pipelines. Open Azure DevOps, go to your project. Over here you can see your project. In your project you can go to pipelines, and here you can see I already have one pipeline. We can start from creating a brand new pipeline by clicking new pipeline here. Now you can select where your code resides. So maybe it's from Azure DevOps Git, Bitbucket, GitHub, and others. You can create your YAML pipeline for this, and or you can create your classic editor pipeline, which is the old style pipeline from use this classic editor link. Microsoft is going away from this classic editor and they are moving all their extensions or creating new extensions for YAML pipelines. So for example, let me click my repository here, parts unlimited, and which type of pipelines I am going to create. It is a ESP.NET, any other pipeline, starter pipeline, or we have so many type of pipelines template already created for us. So for example, I can create deploy to Azure Kubernetes pipeline, Docker image pipeline, Go pipeline. So many. But I don't want to create any special pipeline. I just create a without template pipeline. So what I'm gonna do here, starter pipeline. So in the starter pipeline, I will see only the starter script, nothing else. And then I just this is only a demo I'm creating. I'm just saving it, save and run. I'm pushing it to the master branch. I have removed all the policies right now so that we can quickly finish this demo, and you can see it's running right now. So this is how you can create your pipeline. And now let me show you a demo for our existing pipeline, which is for our project Parts Unlimited. So let me try to run this pipeline in front of you in the master branch. And what this pipeline is going to do, this pipeline is going to build my project, and with the building the project, it will release some artifacts as well from the project. And those artifacts in our next demo, we will try to deploy into our web application. Okay, so our pipeline, this is the build pipeline which is finished now. Let me go to the release pipeline to release my artifact. So before releasing, let me show you, is it any artifact has been released? So in this pipeline which I ran just recently, you can see there is a published artifact. If I open it, I can see some files are released here as an artifact, some environment variables, source code, and etc. So we can use this artifact while we releasing our code to the web application. So let me create this release here. So it is going to deploy my code into dev environment, and it is using the previous pipeline build artifact. Let's create it. In the meantime, when it is running, let me show you how to create a new release. So I just click new and create new release. And here I can see which template, same like build pipeline. Here also we have multiple templates present for us. So I'm just going to choose Azure App Service deployment, apply, and it is asking me which one. So I'm just telling it like QA stage, and then now let me choose artifact from clicking add button. So you can choose artifact from your build pipeline, from your Azure repository, GitHub, and TFVC. I am choosing my build pipeline, so, and the project I have selected here. If you have multiple projects, you can select your project. And now for build pipeline, let me select the build pipeline here. This one we have created recently just for demo, so it is not releasing any artifact. I'm using parts unlimited build. And you see, as I selected this, it automatically has seen that this artifact is getting released from this pipeline. So let me try to add this over here. And in the QA, let me try to authorize it for my web application, which is running in my subscription. So I already have my service principal here, using the service principal, and then selecting my web application which is currently running, parts unlimited 231. And then in the deploy, you can see it has automatically given every information with the help of the templates. And then what I'm gonna do, I'm just going to save it and run it. I don't want to save it because I already have a release pipeline created. So let me just remove it, and let's try to create a new release. But I already created a new release before starting creating the new pipeline. So we already created this new release. Let's go through this release and see the logs. So in the log, you can see it has initialized the job, then it is trying to download the artifacts, and then it is deploying our web application. So in the last, let me try to go in the last. So here you can see total 272 files, and 0 added, 0 deleted, but it has updated 272 files on the web application. So this is how you can run our releases. Now, very important, now I'm going to show you how to create a continuous integration and continuous delivery. So go to the pipeline, let's go to this unlimited one, parts unlimited build, and then added this, and here you can see it is going to trigger on the master. So if I update anything on the master branch, it is going to trigger automatically. Before and after that, going to releases, and I have this release here. Let me edit it, and you can see it is saying continuous deployment trigger. I am enabling this continuous deployment trigger. And what it is going to do, whenever there is a build pipeline runs, after the build pipeline completed, automatically my release pipeline will trigger, and this is called CI/CD, continuous integration and continuous deployment. If we want to add more filters, we can add more filters here, but we don't want any specific filter. And if we want to have a pull request trigger, something like that, we can do that. We don't want that. So I just want to remove this and close this and save this. So now you can see I am adding continuous deployment trigger. So okay, now after continuous deployment trigger, we can see there is a pre-deployment conditions also. This is also very important. If we want to add some triggers here, We can trigger, if we want to add some gates here, we can add gates. So for example, if I am enabling the gate and try to add a gate, so what gates we can add? Check Azure policy compliance first. Try to invoke some Azure function. Try to invoke some REST API which will inform our team that this release is going to be happen, or some others. And we can add some approvals also, pre-deployment approval. So we can enable it, and we can ask that someone from the team should approve it. For example, product owner or your manager, they should approve, then only this deployment will go forward. So we can add this type of triggers, which we don't want to add it right now. And then it will automatically create a deployment. So now test it, how it is working. So go to the repos, and over here, let me try to just update something in the readme file. So let me try to update here in the last. Let me click on edit, adding extra comment, and then commit. And I'm trying to commit in the master branch because right now I don't have any policy enabled on the master branch, so I can commit it directly. But in big organizations, they follow the proper best practices. Then we should not, or we cannot commit directly to the master branch. We have to create a pull request, and then the pull request should be discussed in the team, approval should be provided, and then only we can push our code to the master branch. So let me commit it in the master branch, and master branch has been updated. And now let's go to the pipeline, and you can see my pipeline is just triggered, and it is trying to deploy my code. No, sorry, it is not trying to deploy. It is trying to build my project and release the artifact, because it is a continuous integration pipeline. Now my build pipeline succeeded. Let's see the release is started or not. It's not yet started. Let me refresh. And now you can see the new release has been triggered over here. Let's click on the new release, and my release is already in the queue state. And now it is in progress. It is queue state because it is searching, it is waiting for the resources to run the code, to deploy the code. And once it get the resources from Microsoft hosted agent, it is start deploying. Let me go to the logs, and you can see it has already completed 2 steps, and the third step, which is deploying to the web application, and all steps completed. So this is how you can create your pipeline and enable the continuous integration as well as the continuous deployment. So automatically all the test cases, artifacts, and the final deployment can be done automatically. One more thing I want to show you here, that in the release we can add more releases, more stages over here. So you can add more stages here. This can be like, this can be your stage QA, and then we can add more stages like production, etc. So we can add more stages here, there's no problem. And if we want, we can add more stages after development as well. So for example, this is, for example, let me take it as a production. So once the development is deployed, then only the production deployment will happen. Before development, the production deployment will not happen. So this is how we can create a continuous integration as well as continuous deployment in your Azure DevOps project. Azure test plans. Azure Test Plans provide rich and powerful tools everyone in the team can use to drive quality and collaboration throughout the development process. The easy to use browser-based test management solution provide all the capabilities required for planned manual testing, user acceptance testing, exploratory testing, and gathering feedback from stakeholders. Manual and exploratory testing, which includes planned and manual testing, user acceptance testing, exploratory testing, and stakeholders feedback. Automated testing. Azure Test Plans is fully integrated with Azure pipelines to support testing within continuous integration, continuous deployment. Test plans and test cases can be associated with the build or the release pipelines. Pipeline tasks can be added to the pipeline definition to capture and publish test results. Test results can be reviewed by built-in progress reports and pipeline test reports. Traceability. Test cases and test shoots linked to user stories, features, or requirements supports end-to-end traceability. Tests and defects are automatically linked to the requirements and builds being tested, which also help tracking the quality of requirements. Reporting and analysis. Test results tracking and progress monitoring is supported through configurable tracking charts, test specific widgets that you can add to the dashboards, and built-in reports such as progress report, pipeline test results reports, and the analytics services. Azure Artifacts. Azure Artifacts enables developers to share their code efficiently and manage all their packages from one place. With Azure Artifact, developers can publish packages to their feeds and share it within the same team, across organizations, and even publicly. Developers can also consume packages from different feeds and public registries such as NuGet and npm. Next demo is Azure Artifacts. In Azure Artifacts, let's go to Artifacts, and in the artifacts you can see I don't have any feed here. I don't have anything. It's a fresh new. So what we are going to create for releasing any artifact, we have to create a feed. So let me try to create a feed. This is like feed to all. I want to feed to all, and we have multiple options here. So we can add visibility to all of our Active Directory organization people, only to myself with this project, or specific people they give the name as well. But nobody wants to release their artifact just for themselves. So I am just releasing my artifact for all the Active Directory people, which is whole organization. Then it is asking include packages from public sources, common public sources. I'm also okay with that. And then I'm just scoping it to the parts unlimited or the organization. I'm scoping to the whole organization. Then create it. So it has created feed to all. And now in the feed to all, I'm just trying to add a NuGet package. So for example, searching for one package here. I have one package here, and let me try to save it to feed. And now if I go to my feed here and let me refresh it, you can see I have NuGet package into my artifacts, and now this package can be used internally by all the organization people. Here it is not only for the public packages, but you can also release your artifacts over here, and those artifacts can be downloaded and used by the other team members. And for that, what you have to do, you have to connect first. So if you want to connect to this feed, then you have to click on the connect to the feed, and where you want to use it. I want to, for example, use in Visual Studio. So here you can see this is how the URL which you can use in your Visual Studio to connect to the feed and download these NuGet packages. So this is how you can use the artifacts in Azure DevOps. Summary. Let's summarize what we have learned in this course. We have learned that why we need DevOps for better software with faster releases. We discussed the drawback of traditional software deliveries and how we can overcome with those using DevOps. In Azure boards, we can plan, track, and discuss work across the entire development process. Repos, where we push our code and collaborate with the development team. Pipeline, we have seen how to build and deploy our application with CI/CD pipelines. Azure test plans, we have seen the benefits of automated testing and drive quality in the project. Last but not least, in Azure Artifact, developers can share their work as artifacts within the same team, across organization, and even publicly. Congratulations, you have successfully completed Azure DevOps Getting Started course. If you come here all the way, I would like to say thank you and wish you all the very best for your future DevOps assignments. Feel free to reach out to me in comment section if you still have any doubt or any question to ask. Frankly speaking, I am very responsive to comment section. Tune into my channel if you want to see more learning videos on DevOps, Azure, Terraform, Pulumi, and API development. Bye bye, see you in the next course.